Imagine a world powered by the energy of stars, clean, limitless, and safe. This dream is at the heart of ITER, one of the most ambitious scientific projects in human history. ITER isn't just a reactor, it's a bold promise that humanity can realize fusion energy and shape a sustainable future for generations to come. To understand why ITER matters, we first need to grasp the science that drives it. Nuclear fusion is the process that powers our sun. Two light atomic nuclei, typically forms of hydrogen, fuse to form a heavier nucleus, releasing vast amounts of energy in the process. Unlike nuclear fission, which powers today's nuclear plants by splitting atoms, fusion creates no long-lived radioactive waste and carries no risk of catastrophic meltdown. For decades, scientists have dreamed of harnessing fusion to provide a nearly limitless, safe energy source. Making fusion a practical reality is no small feat. The fuel, usually deuterium and tritium, both forms of hydrogen, must be heated to over 100 million degrees Celsius, hotter than the core of the sun. At these temperatures, matter becomes plasma, a superheated state where atomic nuclei can overcome their natural repulsion and combine. The challenge lies in confining and controlling this plasma long enough for fusion to occur. Major breakthroughs in fusion research began in the 20th century, but scientists knew that what worked in small experiments wouldn't easily scale up. The solution was to create a machine called a tokamak, a donut-shaped chamber using powerful magnetic fields to trap and stabilize the plasma. This concept showed promise, but to achieve the leap from experiments to energy production would require unprecedented international cooperation, resources, and know-how. In 1985, leaders from the Soviet Union, the United States, the European Union, and Japan proposed a collaborative effort to build a large-scale fusion experiment. After years of negotiations and planning, the ITER agreement was signed in 2006. Today, 35 nations, including China, India, Korea, and more, are united in building ITER in southern France. At its core, ITER aims to prove one thing: that fusion can be a viable, controlled source of energy here on Earth. When complete, it will be the world's largest tokamak, designed to produce 10 times more energy than it consumes, a critical leap for the future of fusion power. Specifically, ITER is designed to produce 500 megawatts of output power from just 50 megawatts of input. If successful, it will mark the transition from experimental research to practical energy production. Constructing a machine as complex as ITER is a monumental task. The reactor is built from millions of components, some weighing as much as commercial airliners, sourced from all over the globe. Its central magnet is one of the most powerful ever built, capable of generating a magnetic field 280,000 times stronger than Earth's. These engineering challenges are matched only by the complexity of international coordination, as teams from every member nation contribute expertise, machinery, and materials. Despite obstacles, ITER has achieved remarkable milestones. The assembly of the reactor began in 2020, marking a new era in the project's timeline. In the years since, progress has accelerated. Massive magnets have been installed, the cryostat, the largest stainless steel vacuum vessel ever built, has been assembled, and the project is moving steadily towards its first plasma, expected in the late 2020s. Achieving first plasma will be the moment when ITER successfully confines and heats plasma inside the tokamak, a crucial demonstration that the machinery and magnetic fields can operate as designed. It's a key test ahead of full deuterium-tritium fusion experiments, the step that could finally validate fusion's promise as a practical energy source. If ITER succeeds, it will open the door to a future where fusion reactors can power cities without air pollution, greenhouse gases, or the persistent waste that dogs current nuclear fission plants. The technology developed here could spark new industries, jobs, and drive the world towards true energy independence. Ultimately, ITER is more than a scientific experiment. It's a testament to human cooperation, perseverance, and vision. Every day, people from dozens of countries work side by side, exchanging knowledge and breaking barriers, all in pursuit of a bold common goal: to build a brighter, cleaner future from the very matter of the stars. The road ahead still holds technical and logistical challenges, but each milestone brings the world closer to harnessing fusion power. As ITER's journey continues, it invites all of us to imagine what is possible and to recognize that when humanity joins together, there are no limits to what we can achieve.